And hello to everybody again. In this short video from Learn Electrics, we will discuss the differences between ZE and ZS. A lot of electricians stumble with this one, especially new starters in the trade. It is easy to understand but needs to be approached logically. So here we go. Shown here is a typical drawing for an installation. We are interested in the ZE and ZS readings and what happens during a fault. So here we've only shown the phase conductor or R1 and the earth conductor or R2. We have left off the neutral for clarity at this point. During an earth fault, current will flow from the supply transformer through the consumer unit and the fuses or breakers around the circuits, and a socket circuit is shown here, back along the earth conductor to the transformer, where it is re-energized and recirculates until the breaker operates. We need to know the value of ZS for each circuit, as once we know this value we can compare it to a set of standard tables. If the actual value measured is less than the comparison figure in the tables, then we can be confident that the circuit breakers will operate effectively and keep the users and occupants safe. And there's a little equation here that tells us that ZS is the sum of ZE plus R1 and R2. Here is the same equation. ZE is the impedance or resistance of the external wiring outside the property. Think of ZE with an E for external, outside the property. R1 is the resistance of the phase conductor inside the property, and R2 is the resistance of the earth conductor inside the property. So R1 plus R2 is the internal wiring along which fault currents will flow. How to measure R1 plus R2 is the subject of a separate video from Learn Electrics. Add the outside wiring to the inside wiring and we have ZS. Think of ZS as S for the whole system, inside and outside added together. ZE is shown on its own here. It is that part of the electrical system to and from the supply transformer up to but not including the consumer unit. R1 plus R2 is that part of the system inside the property, from and including the breakers in the consumer unit to the end point of each individual circuit, the lights, the cooker, the shower, or, as shown here, a socket circuit. Add both of these together, the outside and the inside, and we get the whole system. So, when we measure the impedances, we're going to break it down into two steps. First, we will measure ZE on its own, the part inside the dotted box. And then we can measure the impedance of the whole system as shown on this drawing. To measure ZE, the external impedance, we should take two measurements. The first measurement is made with the main earth disconnected from the earth bar in the consumer unit. If we get a reading from this, then this will prove to us that the earth conductor is continuous and that we are not reading through any other conductors or pipework in the property. We are testing the main earth in isolation. The second measurement is made with the earth reconnected to the earth bar so that we can include any parallel paths through pipework or other conductors. We will record the highest impedance or resistance reading as our ZE. Remember, we are now working live. If you are unsure of what you are doing, stop and seek skilled and competent assistance. Electricity is dangerous. This slide clearly shows the earth removed and the main breaker to the property turned off. Also shown are the correct lead positions from your test meter. Shown here is a 3-lead test method. Some modern meters only use 2 leads. Replace the earth and repeat the test as shown. This is method 2. That is now the two ZE test methods completed, and we can record the highest impedance or resistance reading as our ZE. Now we'll move on to ZS, or the whole system. The impedance of the whole length of a circuit from the point of use to the substation and back again. These are still live tests, and at Learn Electrics we always encourage safe working practices. If you are not sure at any time, stop and ask. The main breaker to the property will now be in the on position, as will the breakers for the circuits under test. The meter settings are the same for ZS and ZE. That is, a 3-lead test connected to the phase, neutral and earth respectively, but now at the points of use in the property. ZS, the whole system, is measured at the end of every circuit, the most remote point, the point with the longest length of conductor. Lighting circuits should include the testing of the cables going to the switches, so test lights on the switched side of the ceiling rows, not just on the live loop side. Measure ZS at the lighting point that is furthest from the consumer unit, the light with the longest length of cable. The longest length of cable will give the worst results. If the worst result passes, so will all the other points of use on that circuit. With all the radial circuits, cookers, showers, boiler, radial sockets, again, test at the furthest most remote point. With the socket ring circuit, there is no furthest point, so every socket should be tested. Your testing should include any circuits in outbuildings, garages, garden circuits, etc. Test at the furthest point of every circuit. So, ZE is a measurement of the impedance of the external wiring, E for external, and ZS is a measurement of the impedance for the whole system, S for system. And that is all that there is to it. Hopefully you enjoyed this video from Learn Electrics. More importantly, we hope that you have added more knowledge to your mental toolbox. You can catch us on our Facebook page at Learn Electrics, where we add information and tips on a regular basis. There are many more tech tip videos on our YouTube channel, Learn Electrics. If you click the subscribe button below, you will get access to all of our videos, and you will not miss our next weekly video when it is published. Thanks for watching, and we hope to see you again very soon.